Okay, so once again, hello everyone. My name is Jarek. Yes, I have been testing software for 20 years now. Being paid for it, what is important also. And also I have been working for using machine learning in quality assurance for 10 years now. So today I will share with you some, I believe, some interesting facts about few open source machine learning software quality assurance projects which I participate in. And maybe you will find those projects so interesting that you will also join them and help us make software better for free. Of course, I will talk about the major obstacle regarding machine learning in, software development in general. That's why I named my presentation How to Fit the AI. And for the purpose of this presentation especially, I also asked my artificial intelligence friend, maybe you know him or her, whatever, DALL-E 2. It's a kind of algorithm or tool which generates different images just based on the simple prompt. So you just need to type in some words, and basic on it, this artificial intelligence will generate a picture for you. So that's the title of my presentation. Made as a picture by this DALL-E tool. How to fit the AI, and this is AI, fit with data, or fed with data, let's say. Okay, let's go on. I'm 100% sure that you all know this chart. It is mostly called Boehm's law or Boehm's rule, because many years ago, a guy called Boehm did this discovery, this research, and published that the earlier we will start our quality assurance, the earlier we will start to eliminate defects, bugs from the software, the cheaper it will be. Also, I put just single word in DALL-E tool, artificial intelligence drawing tool, and that's the result. So if you put just a single word cheap into this tool, then you will get such visualization. So if we will try to get rid of defects as soon as possible during those early stages of projects, of software development projects, it will be cheap. It will be cheaper than if we will start our quality assurance later. Another, long time ago, let's say, there was another research, academics guy, let's say, researcher, who was called, I guess, a Manson, and this Manson guy also proposed that we can use machine learning for predicting defective areas in software as soon as possible, as early as possible. So if we have an occasion to meet on a different conferences before, I bet that I talked more or less about the same, predicting defects in the software using machine learning. And 10 years ago, when I started this journey with machine learning in software defect prediction. Together with my friends from the project, we thought that the best approach for using machine learning to predict defects, to get rid of defects as soon as possible, will be to use a tool which is called KNIME, which we found as very easy to use. And I will prove that in a few minutes. But first of all, let's get back to this proposal, this idea of researcher called Manson. Well, he proposed that if we will take data describing our software and mark among all this data which point us to defective parts of the software, then we can train a classifier, machine learning classifier, easy as it is, and then this classifier will be able to predict future defects for us. I also asked DALI for a classifier, for drawing us a classifier, and that's what I got. So this is a classifier drawn by artificial intelligence. Yeah, and the result of this should be such that after we will have new data describing new software, this trained classifier will be able to put additional information next to this data, pointing us to those areas in the software which should be defective in the future. And it was our main idea 10 years ago. Yes, and we thought that it will be easy using KNIME, and maybe, well, it's time for a first demo today. So this is KNIME. It's in the basic form. It's a free software. It's an open source software, so you can get it for free from KNIME website. I also aggregated all those websites under one URL. So at the end of this presentation, there will be a QR code on the screen. You can scan it. There is no viruses under it, just the website with all the other websites I will refer to during this presentation. So nevertheless, this is KNIME. As you can see, we can build data workflows or simply workflows, graphs, using such bricks, nodes, whatever you call it. And then you can use those nodes, those bricks, to do this machine learning, or to, for example, to make happening this idea, this Manson's idea of training classifier, machine learning classifier, and then using it for predicting new defects. And I also gathered training data from a very old open source project, and metrics, code metrics, which describe new release of this open source project. And using this first approach, we found it simple and easy because, as you can see, just to use machine learning, I will find now a node, a brick, which act as a training part of the classifier. Let's use my favorite, which is random forest. Random forest learner. Just I will drag and drop it on the workbench. Pass the data. Okay, let's have a look on this data for a few seconds. You can see right now on the screen code metrics describing different classes in the Java code in a different way. But the most important part of this data is this first column. As you probably can see, it is called defect, and it contains only ones and zeros. And as you probably already know, it is for the purpose for marking those different parts of the code which were defective in the past, those marked with ones, and those marked with zeros, well, turn out to be not really so much troublemaking in the past, let's say. And that's the training data. So we just simply pass this data in our machine learning, well, classifier, learner. Few clicks just to configure it. It properly, does it work? Yeah. It properly found that we have this classification in the column called defect. Click OK. Run it. And that's everything regarding using machine learning and training for the purpose of training our classifier to be used later as a kind of predictor of defects. Looks quite easy, right? There are few catches in this approach, and that's the main topic of my presentation today. But let's just finish this approach. So we have trained a classifier, and we still have new data describing new. Once again, I'm a little bit sick today, so sorry. So this is new data, and the only difference between that old data and this new data is that in this data we lack this first column called defect, because we don't know which parts, which in this case, classes, but we can slice this source code differently. So which classes can be defective or not in the future. The first column this time with zeros and ones is just one of the metrics, the number of overridden methods. So that's the quite common objective coding metrics. Okay, so let's get back to our workflow. Now we will use another random forest brick, which is called random forest predictor. We will pass this new data to this predictor, and we will also pass to this predictor a mathematical model, or we can say knowledge from the brick, from the node which was responsible for training, to the node which is responsible for marking this predictive, software or predictive prediction prone or defect prone, not prediction prone. That doesn't make really sense. But nevertheless, let's start and see what will happen. Once again, this is quick look on the data before this machine learning whole process. New data describing new metrics, describing new software. And if we will take a look in the data after this process, you will notice that we have additional two columns called prediction and called confidence, in short. And that's the result of this 30 years old approach proposed by Manson, when we simply use a predictor classifier to train it using historical data and to use it to point out different areas of the code which should be defective in the future. We can, for example, sort this data, and now at top of this table we'll only have this part of the software which was classified as a defective, or as should be defective in the future. We have a different confidence, as you can see. So that was our first idea. With if we wanted to introduce machine learning to software engineering, to software development process. And well, we thought in our research and development project that well, using such easy tool, it will be really to introduce it. It will be really easy to convince people to use machine learning and to use especially open source tool like KNIME. But to be honest, let's get back to the presentation. We found some issues with that approach. First issue was that well, still, even if we try to convince people that the tool, the approach we proposed is very easy to use, and you will spend just a little time to learn this new tool and to start using machine learning in a defect prediction. Still, in many cases, we faced such situation that, well, team members, different project team members, well, they really even anyhow interested in using another tool, in learning another tool, and so on and so on. And as you probably already find out, this photo also was generated by artificial intelligence, so that's why they are a little bit creepy on this picture. So I put in DALL-E 2 this one sentence, sorry, we have no time, and I got this result. So we had a lot of projects with no time for using machine learning and even easy tools. And another struggle, well, especially now, problem related with that approach was such that we had to use special nodes, special plugins for KNIME to feed data, to put data into KNIME, especially if we talk about such data like records from defect trackers like Jira, for example, or logs from software repositories, and so on and so on. So we had to use a special plugins to KNIME, special mechanisms, which were developed on one of Polish universities, technical universities. Unfortunately, they are no longer developed, as you can see here on this screenshot from GitHub, which I took today in the morning. So that was another problem with this approach, that we relied on the solutions which were not longer up to date. And even I tried this morning to well, reproduce this initial process, this initial idea, and also I found out some issues. Maybe if there will be some time, I will also share those issues with you. So the second idea, a few years later, was to absolutely automate the entire process. And it's such way we started within the project, within the software defect prediction project, we started to develop a solution called ADEPT, which stands for automated or automatic defect prediction. Basically, it's a Python written project which is located on a central, which can be located on a different server, and this server uses its own mechanisms apart from also making use of external tool which is also open source in a basic form, SonarCube, to collect metrics. And then this project located on the central or somehow somewhere in a company on the server can collect. As far as I know, currently it collects data in 3 different companies, so big companies. And so it can automatically collect this data which is needed for machine learning. Then it automatically uses different machine learning algorithms to do exactly the same what I showed you before, a few minutes ago. And then it passes results, those zeros and ones, and also those names of the different source code areas to, we can say stakeholders. To everyone, anyone who is interested in the result, using our JSON. And I was also very curious how AI will draw JSON for us. And this is JSON by DALL-E algorithm. So, nice looking puppy. It's good that we have such ambient light today, because there's something really, really spooky with his eyes. So maybe it's good that we cannot see it properly. At least I cannot see. So, and from the very beginning, ADEPT was an open source project based on the general public license, GNU, and it is also available on different GitHub repositories. For example, on the Jagiellonian University software repository. I put it a fresh version today in the morning. The version located in this repository is a little bit more up to date than the previous tool I showed to you. So basically anyone can download this tool, adjust it to a different coding languages, to a different tools you are using in your projects, and get the results of the software defect prediction done by machine learning. And how to do it? Also some details regarding this approach, but I described also in some books this particular approach. So later I will tell you also about it. We all gonna die for sure, or maybe I shouldn't share with you this classified information. Or I will start to shout, or there is something. I guess the company where I take this screenshot is not very, I don't know, happy about it. Okay, guys. This is just the screenshot from the integrated development environment, in Visual Studio, as you can see in the upper left. And there is a plugin written for the ADEPT tool, which if the developer will start to work with the part of the software which was predicted as a defect prone, then such poor guy will receive such notification that this file contains a hot class, which means that it was classified by algorithm as a defect prone. And then, well, also we developed a special methodology how to deal with such situation that, well, we have such, well, indication on the screen. And regarding testers, especially, well, black box testers or functional testers, we also developed such tool which allows people to translate this raw prediction results into functionalities. And for now, it's only, well, part of this very nice looking and automated tool, which still requires somehow a human input. So a person who knows which parts of the code is responsible for which functions, for which functionalities, have to, well, somehow translate those parts into the functionalities, those parts of the code into the functionalities. Yeah, and regarding this well, methodology I mentioned, it looks like complicated, but it's not. It's, well, basically, if you will have this knowledge, this information that's done that and that part of the code is defect prone or is predicted to be defect prone, then you need to put some special efforts on those areas of the code. Put some additional well, refactoring work or additional architectural principles, and so on and so on. Everything was well described in a very boring form in this book. So if you will be lucky to download it from Chomiko, I mean to find it in the library, you can also get into the details. Also, of course, you can reach me. You can write me an email. That's maybe even easier. Results of the second idea was, for example, such that in the best cases, of course, well, on the conferences you want to talk about the best cases, the best scenarios, the happiest scenarios. So in best cases, we had such results. So, for example, a reduction by almost 70% defects found during system tests. So, well, those, thanks to this methodology, thanks to all those efforts during the early stages of the project, well, we were able to reduce so much defects during system test stages. Also, in one case, we also was able to almost well, completely remove production issues. I mean, defects on the production environment. Thanks to machine learning connected to a proper methodology, to using a proper development practices, and so on and so on. Yeah, but I promised you that not everything is so well, so nice and so successful and so happy to tell you. So there are some problems regarding those techniques, those ideas. First, the obvious problem regarding any machine learning: garbage in, garbage out. So if the project will have crappy data, then well, just simply machine learning will not work, because we need a proper data. We need a well well-maintained historical data to feed it into the machine learning algorithms. And at the same time, in many cases, we faced with situation that, for example, we had a lot defects reported in a defects tracker, which should be somehow connected to a proper source code to train machine learning, but we didn't know which source code, because those defect reports lacked proper version information. And what I mean by proper version information, for example, like this one, that we had in a code repository such versions like, it's a screenshot from my very old, scientific publication from the 2013, so don't bother with that. But as you can see, we have versions with different numbers at the end in the code repository, while at the same time in a defect tracker, we don't have those numbers, only the major version, without any information about this minor revisions. And this is important for creation proper training data for machine learning. And even biggest problem in this general approach, in which we will have a centralized tool for defect prediction, which will collect data from very different sources, especially code metrics from different projects, from different coding languages. The second, even biggest problem was that different tools for measuring code, for measuring processes in our projects, gave us different results, different metrics, different numbers. Even if they measure the same, metrics, to be honest. Two different tools focused on the, for example, cyclomatic complexity. After analyzing the same code, will give us totally different number. Currently, together with my friends, we are finalizing a quite large, also scientific publication about this problem. That we are not, as a software development project members, we are not really aware that, for example, if we will stop using, for example, SonarCube and start using totally different tool for measuring our source code, we will get totally different results. There are so far many research regarding this problem. The problem is huge. So if we have different garbages to put in our machine learning, in many cases you can also hear that we need a unified model, unified tool, which will, without this training phase, which will give us results, give us this prediction, which should be defective, what should be defective in our code and what not. And in my personal opinion, as also a software development researcher, the much bigger problem currently with using machine learning in software development, especially regarding the prediction, is that different tools generate totally different data. So here comes the third idea to solve, for example, the aforementioned problem. And the third idea, third approach, third open source project, and the final today is called Frege. Well, if you are curious what Frege means, then you should ask Professor Adam Roman, because it was his idea. The project is called Frege and is also located on the GitHub. So once again, it's open source, totally free. You can use it, even start using it even today. And the main idea behind this one project is to collect as much data regarding available source code as possible. We want to create a tool which will scan every single possible open source code repository, turn it into the software metrics, and then unify this data and put it on our server to be available for everyone. And we want to also stay with this approach or stay with that idea that this tool should be simple and should be somehow modular. So, for example, if there will be need to scan a brand new, just invented coding language, it will be quite easy to extend this tool to implement also this coding language. So after that, we will because it's still a work in progress. After we will get what we want, what we aim, this very huge repository of code metrics gathered from a different open source repositories. Then, of course, if you are familiar with problems regarding machine learning in software development, you probably can imagine that it will be much easier also to prepare unified models, which will be able to point out defective code without any training, just as it is, because those models were pre-trained on our data. Well, because the tool is open source and the whole idea is kind of open source or based on the Creative Commons. So we want to be open as much as possible and available to anyone. So this is our solution to those problems regarding that in many cases we have crappy data. So we will not need any data after that because the models will be pre-trained basic on the code available. And in such way, I guess I fit nicely in a given time. So it was just a teaser. If you are interested in those ideas, in those projects, you will find URLs, you will find any information needed under this QR code. And if you, you should be suspicious about any QR codes, public QR codes. So you can, for example, write me an email or just use exactly the same URLs on our website, Notatnik Testera, when also those are gathered. So, thank you. I guess that's all.
Thank you, Jarosław, with that amusing content. And now, as regular, any questions? Discord channel empty. Anyone from the room?
There is a gentleman here.
Oh, okay.
No, sorry.
Okay. Hello. So I have two questions. First question. For example, after running of machine learning algorithm, of machine learning tool, you have an indicated class or feature for your QA engineers that this class or this feature might contain potential defect.
So, not really. In a training data, yes, I need this indication from the QA engineers or developers, but in the final data, I will get the same information from the algorithm directly. So I will not need any involvement. Maybe if I will have to translate the pieces of the code into actual functionalities, then yes, unfortunately, I need to ask, well, architects to
Yes,
this.
and the main question, when you have this information, so that some piece of code might contain potential defect, how do you deal with this information next? So, because it might contain defect or might not contain defect. So you put just more attention on this functionality.
Yes, exactly.
Maybe you do something else. Just please explain how you deal with this
Okay,
information.
very shortly, because it's a topic for another presentation. We all know also this one rule of testing, that we cannot test everything in every way. It's simply impossible. So especially in corporations, in companies, we need to plan our testing. We need to focus on some areas, and other areas, let's say, treat some with some less attention. And such output from machine learning can help us with this planning, that we will focus on those areas, because those areas was also indicated by machine learning.
Okay, and my second question, what metrics do you use from SonarQube, for example? So what particular metrics do you
On
guess
the first stage, every metric's available. And then we have a different machine learning algorithm, which will choose from all those metrics available, those which are most efficient.
And which are the most efficient in your case?
Really, it differs depending on the project. Sometimes very simple metrics, like especially when we deal with old coding standards or old coding languages like COBOL, in many cases such metrics like number lines of the code will be enough for such purpose. You're welcome.
Thanks. Any other question?
Time for a break.
Can see, yeah. So thanks again, Jarek.
Thank you. You can hit me an email. Thanks.